Okay, it's time to do Chapter 1, Section 4. You can find this on pages 21 to 23 in your book. And last section, we were writing expressions. Now we're going to move it up one step, and we're going to write equations and inequalities. It's a little bit different, but it's kind of similar. Your objective is to take word phrases and turn them into equations and inequalities. It's very similar to what we did in the last section, excuse me, except now we're going to be using things like equal signs and greater than or less than signs to turn these into equations and inequalities. So let's get right into it. Okay, an equation is just a math sentence that has an equal sign between two expressions. And you know what an equation is, like x plus 1 equals 3. So we're basically be taking word sentences and turn them into number sentences or algebraic expressions by using an equal sign. We're also going to be making inequalities. Excuse me. An inequality is the same thing in math sense, but this time in between the two expressions, we're going to use like the greater than sign or the less than sign. And you may not be familiar with the other two signs, but the greater than or less than, or the greater than or equal to, or the less than or equal to signs. Okay, so this is what we're going to be doing. And just to make sure we understand the signs, here are the new signs we're going to be using. You know the greater than sign and the less than sign. But when you see the greater than sign with a little line underneath it, that means greater than or equal to. And if it's turned the other way, it means less than or equal to. So these are new signs that we're going to be dealing with in this section and throughout the course of the algebra course. Now, sometimes we have an inequality. It could look a little different than what you're used to. And this is going to be a bigger issue when we get to chapter 6, which is all about inequalities. But let's say we had an example of x. And let's say x could be a number greater than 4, or x could be a number that's less than 9. This is a situation that happens quite a bit. So what we can do is take those two inequalities and combine them to make one inequality. And that would look like this. So we have a combined inequality, something like this. X is the number we're dealing with, and this says x is greater than 4. Notice how the greater than sign is facing in this direction. 4 is less than x means x is greater than 4. But x is also less than 9. And this might be a little tricky at first, but as we do more of these, and again, when we get to chapter 6, you're going to be exclusively doing these kinds of problems. I'm sure it'll make a lot more sense. So here's our first examples. Go ahead and hit pause and read these, and then when we get to the next page, we'll solve these, or we won't solve them, but we'll write down what the answers are. All right, so let's take each one of these individually. So the first one's an equation. And when you see the word is, you're dealing with an equation. Is means equals. So this says the difference of twice a number, h, and 8 is 12. Meaning we're going to multiply h by 2 and then subtract 8 from it. And that's going to be equal to 12. So when we write this out, hopefully you've done this already, but if not, what we're going to wind up getting is 2h minus 8 equals 12. So if we read it again, excuse me, the difference of twice a number h, that's 2h, twice a number h. We're having difference, that means we're subtracting, and 8, 2h minus 8, means equals 12. So letter B is a little bit easier. It says the product of 6 and number n is at least 24. Now, at least 24 isn't equals anymore. It means the number could be equal to 24 or it could be greater than 24. So in this case, we're going to multiply 6 times n. And the product can be equal to 24 or it can be greater than 24, which means we're going to use a greater than or equal to sign. And this is 6n is greater than or equal to 24. Now these are tricky. Again, we haven't really studied these over the last year or so. But taking words and putting them into phrases or into mathematical sentences is going to be a big chunk of what we do this year. Now let's take a look at the next one. It says a number y is no less than 5 and no more than 13. That means y is going to be greater than 5, but it's going to be less than 13. So it's one of those combined inequalities we had before, where y is going to be right in between two numbers. And in this case, y is going to be greater than or equal to 5, but it's going to be less than or equal to 13. Now, as you're going through this, if there are questions you have and you don't understand what's going on here, you need to talk to me and ask me. Find some examples in the book, like in your homework pages or at the back of the sections, and come and see me, and we'll sit down together and we'll discuss these. We're probably going to do a bunch of these together in class. But again, changing from words into symbols sometimes can be a little bit tricky. So let's move on. Here's some guided practice question. And this one's an inequality. It's telling us it is. So it says a quotient of a number p and 12. Quotient means we're dividing. P divided by 12 is at least 30. Now we just had an at least problem before. At least means it could equal 30 or it can be a little bit more than 30. So we're going to use a greater than or equal to sign. So if you think about it, this is just going to be p divided by 12 is greater than or equal to 30, just like this. So we're off to a good start, but again, you're going to need to do a bunch of examples and practice to make this into a skill that you're very good at. Now, before we get into the chapter or the section where we're going to be solving equations or solving inequalities, we need to know how to find whether a number is a solution to an inequality or an equation. So any number or numbers that make one of these things true is called a solution, which makes sense because you're solving an equation. So when you solve, you're finding a solution. So don't bother writing this down. Just kind of follow along. And what they're asking us in your book is this. If we put 3 into this equation, is 3 going to be a solution? So what we're going to do is substitute 3 in for x and ask ourselves. Notice we have the little, is it equal to sign there? Is 8 minus 2 times 3 equal to 2? Well, 2 times 3 is 6, and 8 minus 6 is 2. So in this case, 3 is a solution to the equation. In fact, it's the only solution. Second one, what if we have 4x minus 5 is equal to 6? Well, we throw 3 in there. 4 times 3 is going to be 12. 12 minus 5 is going to be 7. Is 7 equal to 6? Of course not. So in this case, 7 is not equal to 6. So we'd say no, 3 is not a solution to the equation. Now an inequality. This time, we're going to substitute 3 for z. And the question is asking us, if we multiply 2 times 3 and add 5 to it, is that going to be greater than 12? And since 2 times 3 is 6, and 6 and 5 is 11, we know this is false. So since 11 is not greater than 12, this is not a solution to the equation, or the inequality. Finally, our last one. We have 5 times 3 times n, or 5 plus 3 times n, and we're asking is that less than or equal to 20? And we're going to substitute 3 for n. And this is math you do in your head. This isn't really that difficult. 3 times 3 is 9. 5 and 9 make 14. Is 14 less than or equal to 20? And of course, since it is, we would say yes, 3 is a solution to this inequality. So not really the hardest stuff in the world, but it's a good way to get started before we get into the equations on solving equations, or the chapters on solving equations and solving inequalities. So now mentally in your head, ask yourselves, is the number in red a solution to the equation or the inequality that they're asking? So look at the first one. Is 9 minus 5 equal to 4? Sure it is. So we would say that yes, 5 is a solution. How about the second one? If we substitute 7 in for b, 7 plus 5 make 12. And 12 is less than 15. So yes, again, 7 is a solution to the equation. And finally, the last one. It's the first time we've had a problem like this. 2 times 9 plus 3, is that going to be greater than or equal to 21? Well, 2 times 9 is 18, and 18 plus 3 is 21. Now, 21 is not greater than 21, but 21 is equal to 21. So once again, that would be a solution to this inequality. Here's a few more. We solve these in your head. And again, I don't think these would give you much of a problem, hopefully. All right? So for the first equation, if we add 5 to 6, we get 11. So the solution is m equals 6. Number 6 is asking us, what number times 5 makes 40? And you all know that's 8. And finally, number 7 saying, what number divided by 4 gives you 10? Well, that number is going to be 40. So 40 divided by 4 is 10. Okay? And again, we're not in chapter 5, 6, 7. We're in chapter 1. We're just going over the basics, making sure you're okay with the things that you should know by now. So now we're going to get into a word problem. This is what I kind of told you to turn into. We're going to take the word problem, and we're going to turn it into an equation. So as you read this, says last time you and 3 friends went to a mountain bike park, you had a coupon for $10 off, but you paid $17 for 4 tickets. And the question is, what's the regular price for 4 tickets? Again, not a very challenging question, but they want you to write the equation in symbols first and then solve it. So let's do that now. All right, if I want to find how much I paid or how much it would cost for a regular price, we don't know the regular price, but we do know the coupon was worth $10, and we know that we paid $17. So we can substitute those in. So P is going to be the regular price. We're going to take away the $10 coupon, and we know that we paid $17. So our equation is going to be P minus 10 equals 17. And again, you do this in your head. We know that $27, take away 10 is $17. So the regular price for 4 tickets to the mountain bike park would be $27. And again, in this case, the goal wasn't so much to figure out what the number was, but to write the expression. And in this case, the equation was P, the regular price, take away the coupon, gives you the amount that you paid. P minus 10 equals 17. And now here's our final example. This time we're going to be dealing with an inequality. So take a second, maybe hit pause, read the question, and then on the next page we'll solve it together. Okay, so let's do this. The question says the basketball player scored 351 points in the last season. If they have 18 games and he averages 20 points per game, PPG, points per game, is that going to be enough to beat his last year's total? So again, this is an inequality. We want to know if it's at least going to be 351. So the question is this: 18 times x, or p, the number of games he plays, is that number greater than 351? Now they're telling us 20. Is 20 points enough to beat the average, or to beat his total points? So we're going to substitute 20 in for p and ask ourselves, is 18 times 20 greater than 351? You can probably do that multiplication in your head as well. 18 times 20 is 360. And of course, 360 is greater than 351. Now, here's one of those things about this math class that you got to understand. When we're given a word problem, we answer in words. So we just can't write down yes or no. We're going to write down that yes, an average of 20 points per game is going to beat last year's total. So whenever you have a word problem, you're going to answer in words. And of course, your number answer. Okay? That was pretty quick. So we're done with section 1.4. There is no section 1.5. 1.5 is just solving word problems, and we do that kind of on a daily basis. So we're going to skip that. And just after you're done with section 1.4 work, which you can find on page 24 in your book, we're just going to move right to section 1.6. Okay? So if you have any questions, if you're kind of unsure about the signs like the greater than or equal to, or the less than or equal to sign, or less than or equal to signs, come and see me. If there's any questions in the work that you're not sure of, see me. Make sure you check your answers with the answer sheets on the wall, and show me your work when you're done so you can move on to the next section. Thank you.